The massive building stood tall against the purple sky of the neutral world. The Galactic Institute of Advanced Sciences was home to students from every corner of known space. Today, hundreds of alien students filled the large lecture hall, waiting for their professor to begin the class. Professor Zalthor moved to the front of the room. His blue skin shimmered under the lights, and his 6 tentacles moved with purpose as he prepared the holographic display. He was a Viridian, one of the most respected teaching species in the galaxy. His reputation for brilliant lectures had drawn students from dozens of worlds. The seats were filled with creatures of all shapes and sizes. The Kryn sat in the front rows, their 4 eyes blinking in sequence as they reviewed their notes. These insect-like beings were known for their logical minds and perfect memory. Behind them, the ethereals floated in their special containment fields, their ghostly forms humming softly. The tall Bronthar had to use the reinforced seats in the back, their massive bodies making the metal creak slightly. Scattered among these aliens were 3 humans. Lieutenant Jake Morrison sat near the middle of the room, looking relaxed as he checked his data pad. He wore the simple uniform of Earth's space fleet, dark blue with silver trim. Next to him sat Dr. Lisa Parker, a civilian scientist who had joined the exchange program. She was making notes in her personal journal, her brown hair pulled back in a practical style. The third human, Commander Ryan Hughes, sat with his arms crossed, watching everything with quiet interest. Professor Zalthor activated the main display. A 3-dimensional image appeared in the air above him, showing 2 spacecraft in the darkness of space. One was small and simple in design. The other was enormous, covered in weapons and armor plating. "Welcome, students," the professor began. His voice was translated into dozens of languages simultaneously by the hall's systems. "Today, we will study an interesting case. We will examine what happens when a species with primitive understanding tries to fight against advanced technology." A wave of curious sounds filled the room. Clicks, hums, and other noises showed that the students were interested. "Our subject today is humanity." The professor gestured toward the hologram. "Specifically, we will watch their recent battle with a Dravok warship. The humans are new to galactic society. They have only been traveling between stars for a short time. Their technology is basic compared to most civilized species." Some students turned to look at the 3 humans in the room. Jake noticed the attention but kept his expression neutral. Lisa continued writing in her journal. Ryan simply raised one eyebrow. "The Dravok, as you all know, are master engineers," Zalthor continued. "Their warships use technology that most species cannot even understand. Their weapons can destroy planets. Their shields can stop almost any attack. They are feared throughout this sector of space." The hologram zoomed in on the Dravok vessel. It was truly impressive, with angular plates of dark metal and rows of glowing weapon ports. The design spoke of power and destruction. "Now observe the human ship." The image shifted to show the smaller vessel. "This is called the Defiant. It is a frigate, which means it is designed for small battles and patrol missions. Look at its size compared to the Dravok ship. The alien vessel is more than 40 times larger. It has more weapons, stronger shields, and faster engines." A Kryn student in the front raised one of its thin arms. "Professor, why would the humans engage such a superior opponent? Did they not scan the enemy vessel first?" Zalthor's tentacles rippled in what his species used as a smile. "Excellent question. Yes, they did scan the Dravok ship. They knew exactly what they were facing, and yet, they chose to attack anyway." Laughter erupted throughout the hall. The students found this hilarious. Several made comments in their own languages about human foolishness. But here is where it becomes truly entertaining, the professor said, clearly enjoying himself. "Let me show you their battle plan, the strategy they filed." With their fleet command, numbers and equations appeared on the display. They were written in human mathematical notation, but the translation systems made them readable to all species present. The laughter grew louder. An ethereal spoke up, its voice translated from its natural frequency into audible speech. "Are those chemical rocket equations?" "Professor, surely you are joking." "I am not joking," Zalthor replied. The humans actually used chemical thrusters for their maneuvering. In this age, when any proper civilization uses quantum thrust or gravity manipulation, they used controlled explosions to push their ship around. More laughter filled the room. A tall Thrix clicked its mandibles rapidly, which was how its species showed amusement. "What century are they living in?" The professor pulled up more human equations. "It gets better. Look at this." They based their entire tactical approach on something they call Newtonian physics. This is a framework developed by one of their ancient scientists, long before they even left their home planet. It treats space as a simple, empty void, and uses basic mathematics to predict motion. A Bronthar's deep voice rumbled from the back. "Do they not understand quantum field theory? Dimensional mathematics? Even basic graviton manipulation? Apparently not well enough to use it in battle," Zalthor answered. "Their ship's computer uses these primitive calculations. Force equals mass times acceleration. Energy equals 1/2 mass times velocity squared. Such simple equations that our children learn them as historical curiosities." Lisa Parker's hand tightened on her pen, but she still said nothing. Jake glanced at her and gave a small shake of his head. Ryan continued to watch the professor with an unreadable expression. "I want you all to understand something," the professor said, his tone becoming more serious. "The humans are not stupid. They are simply working with limited knowledge. They have not had thousands of years to develop their sciences like we have. They are doing the best they can with what they know. But their best is not enough when facing truly advanced technology." He brought up an image of the human who commanded the Defiant. Captain Gregory Foster looked to be in his 40s, with gray hair and a stern expression. This is their commander. By human standards, he is considered brilliant. He graduated top of his class at their naval academy. He has won several battles against other human ships, but against the Dravok, his primitive physics would not be enough. A student called out from the middle rows, "Professor, how long did the battle last?" Zalthor's tentacles curled with satisfaction. "That is what we are going to watch. I want you all to predict the outcome first. Given everything you know about the Dravok and about human technology, what would you expect to happen?" Answers came from all over the hall. The human ship would be destroyed immediately. Perhaps 30 seconds at most. I say 15 seconds. 10 seconds, if the Dravok gunner is skilled. The professor nodded at each prediction. All logical conclusions. The technological gap is simply too large. Advanced weapons against primitive defenses. Quantum shields against chemical explosives. Graviton beams against metal armor. The outcome should be obvious. He turned back to the display and prepared to start the recording. "Now, I must warn you that this footage may be difficult to watch. The destruction of the human vessel is quite thorough, but it serves as an excellent lesson about the importance of advanced scientific understanding. Watch carefully, and think about what advantages proper technology would have given the humans." The lights in the hall dimmed. The holographic display expanded to fill the space above the students. The timestamp appeared in the corner, showing the date and time of the battle. The Dravok warship hung in the darkness of space, patient and deadly. In the distance, moving closer with each second, came the small hue. The holographic display showed space in perfect detail. Stars glittered in the background like scattered diamonds on black cloth. The Dravok warship, called Vorath's Fang, dominated the center of the view. Its hull was dark gray, almost black, with edges that looked sharp enough to cut. Weapon ports glowed with contained energy, giving the massive vessel an appearance of barely controlled violence. From the right side of the display, the human frigate Defiant approached at steady speed. Compared to the Dravok ship, it looked tiny and fragile. Its hull showed scratches and burn marks from previous fights. The design was simple and functional, without any of the elegant curves that many alien ships displayed. It looked like what it was: a working military vessel, built for practical purposes, rather than beauty. The distance counter in the corner of the display showed the two ships were 50,000 kilometers apart. That was close range for space combat, where battles often happened across hundreds of thousands of kilometers. Professor Zalthor spoke as the recording played. Notice the human approach vector. They are traveling in a straight line through normal space. No dimensional shifting. No quantum jumps. They are simply flying toward the enemy, using conventional thrust. The Dravok captain must have been quite amused. Several students chuckled at this. The idea of approaching a superior enemy in such a straightforward manner seemed foolish to them. The Vorath's Fang opened fire first. Brilliant beams of concentrated energy lanced across the darkness. Each beam carried enough power to melt through the armor of most ships. The energy readings appeared on the side of the display, showing numbers that made several students gasp. One hit from those weapons would vaporize the small human frigate completely. But something unexpected happened. The Defiant suddenly dropped downward in space. Its maneuvering thrusters fired in a sharp burst, pushing the ship away from its previous position. The energy beams passed through empty space where the human vessel had been just moments before. The deadly weapons hit nothing but vacuum. A Kryn student spoke up. A lucky guess. The human captain must have fired his engines at random and got fortunate. Other students murmured agreement. Random luck was the only explanation that made sense to them. The Dravok ship adjusted its aim. The massive vessel's targeting computers recalculated the firing solution in microseconds. This time, multiple weapon banks fired at once. 6 separate energy beams created a spread pattern that should have been impossible to avoid. The kill zone covered thousands of cubic meters of space. Any ship in that area would be hit by at least one beam, probably more. The Defiant moved again. But this time, its motion was even stranger. The ship spun on its central axis, while simultaneously accelerating at an odd angle. It twisted through space in a way that looked almost random. The energy beams passed around it, some missing by only meters. The human ship emerged from the attack, completely undamaged. The lecture hall was quieter now. Students leaned forward, their attention fixed on the display. This was not going as they expected. They must have better equipment than we thought, an ethereal suggested. Perhaps their sensors can predict weapon fire. Lisa Parker smiled slightly at that comment but remained silent in her seat. The Vorath's Fang fired again. This time, it added missiles to the attack. Dozens of self-guided weapons streaked toward the Defiant, their engines leaving bright trails across the display. Each missile carried a warhead powerful enough to crack a small moon. Combined with the energy beams, the attack should have been overwhelming. The human ship's thrusters fired in what looked like a chaotic pattern. Short bursts from different angles made the Defiant tumble and spin through space. It accelerated, then decelerated, then accelerated again in a different direction. The movements seemed to have no pattern at all, yet somehow, every missile missed. Every energy beam hit empty space. The Defiant continued its approach, now closer to the Dravok vessel than before. A Thrick student clicked its mandibles in confusion. How are they calculating those movements? The processing power required would be enormous. Jake Morrison spoke from his seat, his voice carrying clearly through the quiet hall. It's not that complicated. Every weapon has a travel time. Energy beams move at light speed, but they still take time to cross distance. Missiles have acceleration curves. If you know where a weapon is fired from, and when, you can calculate where it will be. Then you just need to be somewhere else. Several heads turned to look at the human, but most eyes stayed on the display. The battle was becoming very interesting. The Defiant continued its strange dance through space. Its movements looked wild and uncontrolled, but it never got hit. The ship would roll, then pitch, then yaw in seemingly random combinations. But each movement placed it exactly where the enemy weapons were not. Captain Foster's voice came through the communication log. All stations. Maintain evasive pattern Delta. Engineering. I need everything the reactors can give us. Weapons. Stand by for firing solution. The human captain's voice was calm and steady, showing no sign of panic or fear. He spoke like someone following a plan, rather than desperately trying to survive. Professor Zalthor had stopped his commentary. He watched the display with his tentacles held very still, which for his species indicated deep concentration. The Vorath's fang changed tactics. Its main weapon port began to glow with a different kind of energy. The light was deep purple, and it seemed to bend space around itself. The distortion was visible even through the holographic recording. The graviton beam, Abronthar said quietly. They are using their most powerful weapon. Several students nodded. The graviton beam was feared throughout the galaxy. It created an artificial gravity well that could crush ships like tin cans. The weapon had a success rate of 97% against vessels without quantum stabilizers. A simple human frigate with primitive technology would have no defense against it. The purple beam lanced out from the Dravok ship. Space itself seemed to twist along its path. The graviton field reached out toward the Defiant, creating a tunnel of crushing gravitational force. Anything caught in that beam would be compressed to the size of a basketball within seconds. The human ship's response made absolutely no sense to the watching students. Instead of running away from the beam, the Defiant turned toward it. The ship's thrusters fired, pushing it at an angle that seemed designed to intercept the graviton field rather than avoid it. Several students gasped. Was the human captain surrendering? Had he lost his mind? The Defiant entered the edge of the graviton beam. The ship began to accelerate, pulled by the artificial gravity. But just as it seemed the human vessel would be caught and crushed, its main engines fired at maximum power. The timing was perfect. The ship used the gravitational pull to whip around in a tight curve, like a ball on a string being swung in a circle. The Defiant's speed increased dramatically. The velocity readings on the display jumped to numbers that made the sensor systems struggle to keep up. The human ship shot out of the graviton beam's far side, now traveling much faster than before and on a completely different course. What just happened? A Kryn student asked, all four eyes wide with confusion. Jake Morrison answered before the professor could. Gravity assist. You let a gravity source pull you in, then use your engines when you're closest to it. The gravitational energy adds to your thrust, and you come out moving much faster than you went in. We've been using that trick to explore our own solar system for over a century. Ryan Hughes added, it's basic orbital mechanics. The math is simple if you understand how gravity and velocity work together. The Defiant was now hurtling toward the Vorath's fang at incredible speed. But more importantly, it was approaching from an angle the Dravok ship had not expected. The massive alien vessel began to rotate, trying to bring its weapons to bear on this new threat vector. But the Dravok ship was huge. Its mass was 40 times greater than the human frigate. That same mass that gave it superior armor and firepower now worked against it. The ship turned slowly, ponderously, like a whale trying to change direction in water. The Defiant, small and light, could change course much more easily. Its thrusters fired again, adjusting the approach angle. The human ship began to spiral, creating a corkscrew path through space. They're building angular momentum, Lisa Parker said quietly to her companions. Watch what happens next. The Vorath's fang fired everything it had. Energy beams created a web of destruction. Missiles launched in massive waves. Point defense cannons filled space with solid projectiles traveling at tremendous speeds. The amount of firepower being released was staggering. Any one of those weapons should have connected with the human ship. The Defiant hovered in position above the Dravok warship's main reactor section. The gap between shield emitters was small, perhaps only 100 meters wide. For a ship traveling at combat speeds, threading that needle should have been impossible. Yet the human frigate sat there, perfectly positioned, as if it had all the time in the world to line up its shot. The weapons that emerged from the Defiant's hull were not impressive to look at. No glowing energy ports. No quantum disruptors. No graviton emitters. Just 6 simple magnetic rail launchers, their barrels extending from the ship's ventral surface. The weapons looked crude compared to the sophisticated systems on the Dravok vessel. Inside the Defiant, as the recording showed from internal cameras, the crew worked with focused intensity. The weapons officer, a young woman named Katie Nash, had her hands on the firing controls. Her displays showed a perfect target lock on the reactor housing below. "Solution locked and confirmed," she reported. "Kinetic impactors ready. Safety's off." Captain Foster sat in his command chair, watching the tactical display with experienced eyes. He was old enough to have gray in his hair, but young enough to still serve on the front lines. His uniform was neat, and his expression was calm. He looked like a man who had done this many times before. "All crew, brace for recoil," Foster ordered. "Fire when ready, Lieutenant Nash." The weapons officer pressed the firing button. The magnetic rails hummed with power as they activated. In the space of 2 seconds, all 6 rails fired their projectiles. The weapons themselves were almost absurdly simple. Each one was a solid rod of tungsten, a dense metal that could withstand enormous heat and pressure. The rods were 2 meters long and 30 centimeters thick. They had no guidance systems, no explosive warheads, no complex technology at all. They were just heavy metal rods wrapped in a layer of ablative material to protect them from the heat of atmospheric entry. But simple did not mean weak. The magnetic rails accelerated each rod to a significant fraction of light speed. The tungsten impactors left the Defiant's weapons ports, traveling at speeds that made them effectively invisible. At that velocity, each rod carried kinetic energy that made nuclear weapons look weak by comparison. The math was simple. Kinetic energy equals 1/2 the mass times the velocity squared. When velocity gets high enough, even a small mass carries devastating energy. The 6 rods covered the distance to the Dravok ship in less than 1/10 of a second. They punched through the gap in the shields without slowing down. The first rod hit the reactor housing's outer armor plate. The impact released energy equivalent to several thousand tons of conventional explosives. It was pure kinetic force, the tungsten rod transferring all its momentum into the target in a single instant. The armor plate crumpled like paper. The rod punched through and hit the secondary containment layer. The second rod struck a fraction of a second later, then the third, fourth, fifth, and sixth. Each impact drove deeper into the Vorith's Fang's vital systems. The Dravok ship's armor was strong enough to resist energy weapons and survive missile strikes. But kinetic energy at those speeds was different. There was nothing to disperse, no heat to radiate away. Just pure force driving solid matter through solid matter. The impacts created shock waves that traveled through the Dravok ship's structure. The Vorith's Fang's massive size, which had been its strength, now became a weakness. All that metal and composite material transmitted the shock waves perfectly. Deep inside the warship, safety systems detected the damage to the reactor housing. Automatic protocols activated immediately. The reactor began an emergency shutdown sequence, called a scram. Within 3 seconds, the fusion reaction stopped. Power dropped throughout the vessel. Weapon systems went dark. Shields collapsed. Life support switched to emergency batteries. The mighty Dravok warship, which had destroyed dozens of enemy vessels over its career, went completely dark. It drifted in space, powerless and helpless. Not destroyed, which would have been wasteful, but thoroughly disabled. The crew was alive, but unable to fight. Their ship had become nothing more than a very expensive piece of space debris. The Defiant pulled away from the crippled warship, its thrusters firing in careful bursts. The human frigate established a safe distance and held position, keeping its weapons pointed at the Vorath's fang in case the Dravok crew tried something desperate. Captain Foster's voice came through the communication log one final time. "Damage report." A different voice answered. Probably the engineering officer. "Hull stress at acceptable levels. Shield generators took some damage from the near misses but are still functional. Reactor output, normal. We're down to 60% munitions. Overall, we're in good shape, sir." "Outstanding work, people," Foster said. "Maintain alert status. Broadcast our standard surrender terms to the Dravok ship on all frequencies." The holographic display froze on that final image. The Vorath's fang, floating dead in space. The Defiant, maintaining its watchful position nearby. The timestamp showed the entire engagement had lasted less than 4 minutes from first shot to final impact. The lecture hall was absolutely silent. Nobody moved. Nobody spoke. The alien students stared at the frozen image, as if they could not believe what they had just witnessed. Professor Zalthor stood motionless at his podium. His tentacles hung limp. His normal, confident posture completely gone. He looked like someone had just explained that water was not actually wet or that gravity did not really exist. Finally, a young Kryn in the front row broke the silence. Her voice was quiet, almost a whisper. "How? We saw it happen, but I do not understand how it was possible." More students began to speak, their voices overlapping. Questions flew through the air in a dozen languages. How did the humans calculate those movements? How did they avoid all those weapons? How did they find that gap in the shields? How did simple metal rods destroy such a powerful ship? Lisa Parker stood up from her seat. Her movement drew every eye in the amphitheater. She looked at Professor Zalthor and asked politely, "May I explain?" "Professor?" Zalthor's tentacles moved in a gesture that his species used for uncertain agreement. "Please do, Dr. Parker." Lisa made her way down the stairs to the front of the hall. Her footsteps echoed in the large space. She moved with confidence, like someone about to explain something she understood perfectly. When she reached the podium, she tapped her datapad and rewound the holographic display to the beginning of the engagement. "What you just witnessed," she began, her voice clear and strong, "was not luck. It was not some secret human technology. It was the application of fundamental physical laws that have existed since the beginning of the universe." She paused and looked around the room, making eye contact with students from different species. "Your professor told you that human physics was primitive. He was wrong, not because our physics is advanced, but because there is no such thing as primitive or advanced physics. There is just physics. The universe follows certain rules, and those rules do not change based on how sophisticated you are." Lisa highlighted the first evasive maneuver on the display. Captain Foster did not guess where those energy beams would go. He calculated their paths. Energy beams travel at light speed, which means they take time to cross distance. From 50,000 kilometers away, it takes about 1/6 of a second for a beam to reach its target. That's not much time, but it's enough to move if you know exactly when and where the weapon fired. She brought up the mathematical equations that had appeared in the human battle plan. "These equations that you laughed at earlier, they let us predict exactly where a beam will be at any given moment." The Dravok targeting computers were very sophisticated. They calculated millions of possible trajectories and chose the best firing solutions. But they assumed the target would try to outrun the beams or would maneuver randomly. Captain Foster did neither. He calculated where the beams would be and made sure he was somewhere else when they arrived. A Thrick student raised a claw. "But the processing power needed for those calculations is less than you think," Lisa interrupted gently. "Because we were not calculating quantum probabilities or dimensional variances. We were tracking position, velocity, and acceleration in three-dimensional space. That's not complicated mathematics. It's just precise mathematics. Every human child learns these equations in school by the time they are 12 years old." She moved the display forward to show the gravity assist maneuver. "Now, This is where understanding basic physics really helped us. The Dravok captain thought his graviton beam was a weapon. Captain Foster saw it as an opportunity. Gravity is gravity, whether it comes from a planet or an enemy weapon. If you understand orbital mechanics, if you know how to calculate a trajectory through a gravitational field, then you can use any gravity source to your advantage. Ryan Hughes stood and walked down to join Lisa at the front. The Dravok captain made a mistake that many advanced species seem to make, he said. He assumed that old knowledge was useless knowledge. The mathematics we used to perform that gravity assist was developed in the 20th century by human scientists studying how to send probes to other planets. It's old math, yes, but it's correct math. And correct math does not stop working just because you discovered something newer. Jake Morrison joined his colleagues at the front of the hall. Here's what I want you all to understand, he said, addressing the students directly. Technology is wonderful. Your quantum drives, your energy weapons, your dimensional shields, they're all impressive achievements. But technology is just tools for working within physical laws. You cannot break those laws no matter how advanced you become. You can only find clever ways to use them. Lisa brought up the final attack run, showing the Defiant's corkscrew approach through the defensive fire. This is the part that seems most impossible to you. All those weapons firing, creating what should have been an unavoidable wall of destruction. But every single weapon followed predictable physical laws. Energy beams travel in straight lines unless affected by gravity or magnetic fields. Missiles accelerate based on their thrust, and Professor Jalthor slowly moved back to his podium. His tentacles curled and uncurled with uncertainty. For someone who had taught at the Galactic Institute for over 20 years, this was clearly an uncomfortable experience. Being wrong was one thing. Being proven wrong in front of hundreds of students was quite another. I believe, he said carefully, that I owe our human colleagues an apology. I presented this case study as an example of primitive thinking. But now I see that my own understanding was insufficient. Lisa nodded graciously. There is no need for an apology, Professor. But perhaps this can be a teaching moment for everyone here. She turned to face the assembled students. The diversity in the room was remarkable. Beings with scales, fur, chitin, and energy fields all sat together, united in their desire to learn. Right now, they were all focused completely on what the humans had to say. Technology advances, Lisa continued. We discover new things, develop new tools, find new ways to manipulate the universe around us. That is progress. And progress is good. But progress does not mean abandoning fundamentals. It means building on them. The tallest building still needs a strong foundation. The most advanced spaceship still has to follow the basic laws of motion. Ryan pulled up several other human victories in recent conflicts. Each one showed a similar pattern. Human vessels facing superior opponents and winning through precise application of fundamental physics. There was the frigate Jackson, which had escaped from 3 Thrix cruisers by using planetary gravity to slingshot away at speeds the enemy could not match. There was the destroyer Baltimore, which had disabled a pirate base by calculating the exact angle needed to bounce kinetic rounds off an asteroid and hit the base's power generators. In each of these battles, Ryan explained, human forces were outgunned and out-teched. The enemy had better weapons, stronger shields, and more advanced equipment. But they had forgotten something important. Fancy technology does not exempt you from the laws of physics. It just gives you more options for working within them. A young ethereal raised a question. The translation system rendered it as, "Are you suggesting we abandon our advanced technologies?" Loader Bay, "Not at all," Jake responded quickly. "Your technology is impressive and useful. Quantum drives let you travel faster than we can. Graviton weapons give you capabilities we do not have. Energy shields protect you better than our armor plating. By all means, use those advantages. But do not forget the basics while you are using them." He brought up an image of Earth's Naval Academy, where human officers trained. This is where we teach our future captains and commanders. They learn to use fusion drives, magnetic accelerators, and energy shields. But before they touch any of that advanced equipment, they spend 2 years learning classical mechanics. They learn to calculate trajectories by hand. They learn to understand force, energy, momentum, and acceleration at an intuitive level. Lisa highlighted several sections of the human training curriculum. We make our students solve navigation problems without computers first. Not because we enjoy making things difficult, but because we want them to understand what the computer is calculating. When Captain Foster performed that gravity assist maneuver, he did not just trust his computer to plot the course. He understood the forces involved, understood the energy transfers, understood the physics of what was happening. If his computer had failed, or given a wrong answer, he could have checked it manually. That seems inefficient, Akrin observed. But the tone was curious now, rather than dismissive. The earlier mockery had completely disappeared from the room. Perhaps it is inefficient in some ways, Ryan admitted. Training takes longer when you teach fundamentals first, but it means our crews do not become dependent on technology they do not understand. When something unexpected happens, when an enemy uses a weapon we have not seen before, when our systems get damaged in battle, our people can adapt. They can look at the situation, apply fundamental principles, and find solutions. Professor Zalthor had been checking data on his personal pad while the humans spoke. Now he looked up, his expression troubled. I have been reviewing the military records, he said slowly. In the past galactic year, human forces have engaged in 43 combat situations with technologically superior opponents. The human success rate is 89%. I had dismissed these victories as luck or incomplete data. But now, I see a pattern. You are not getting lucky. You are applying knowledge that we have forgotten. Not forgotten, Lisa corrected gently. More like taken for granted. Your technology is so good that you do not need to think about the basics most of the time. Your computers handle the calculations automatically. Your ships compensate for physical forces without requiring crew input. That is wonderful for normal operations. But in combat, when your computer might be damaged, or when you face unexpected situations, relying on technology alone can be dangerous. Jake pulled up one more image. It was a simple diagram showing force vectors, acceleration arrows, and trajectory curves, the kind of illustration that appeared in basic physics textbooks. This is what we want you to take away from today. Do not dismiss simple things just because they are simple. Do not ignore basic principles just because you have moved beyond them in your technology. The universe runs on these rules. Every exotic piece of technology you have developed is just a sophisticated way of working with or around these fundamental laws. He gestured to the frozen image of the Vorith's fang, still visible on the main display. The Dravak had better technology than us. They still do. Their weapons are more powerful, their shields are stronger, their ship is larger and tougher. But they forgot something crucial. They let their computers do all their thinking. They trusted their superior firepower to win battles. They forgot that a smaller, weaker opponent who truly understands physics can sometimes find solutions that brute force cannot match. Ryan stepped forward for the final point. We are not saying human physics is better than your advanced sciences. We are saying it is the same physics. The universe does not have multiple sets of rules, one for primitive species and one for advanced ones. There is just physics, and it applies to everyone equally. An object in motion stays in motion. Every action has an equal and opposite reaction. Energy cannot be created or destroyed, only changed from one form to another. These are not human laws. They are universal laws. Lisa smiled. Captain Foster proved something important in that battle. Understanding fundamentals can be just as powerful as having advanced weapons. Maybe more powerful, because fundamentals never fail. They do not malfunction. They do not depend on having the right equipment or the right conditions. They are always there, always working, waiting for someone smart enough to use them. Professor Zalthor stood straighter, some of his normal confidence returning. Then I propose we revise the conclusion of this lecture. This is not a case study in primitive thinking. This is a case study in the power of fundamental understanding, and perhaps a lesson about the dangers of academic arrogance. That last part was clearly difficult for him to say, but he said it anyway. Several students made sounds of approval in their various languages. The Kryn student in the front row raised her hand. Dr. Parker, Commander Hughes, Lieutenant Morrison, could you teach us, not just the equations, but the way humans learn them? The understanding behind the mathematics? Lisa exchanged glances with her colleagues. Jake nodded. Ryan smiled. They had hoped the aliens would ask. We would be happy to, Lisa said. But I should warn you. It starts very simple. Really simple. Forces, mass, acceleration, basic geometry. You might feel like you are going backward before you move forward. You will spend time on concepts that you think you already know. After what we witnessed today, an ethereal chimed in, I think we could all benefit from going back to the beginning. Clearly we missed something important the first time we learned these concepts. Sounds of agreement filled the room. Clicks, hums, rumbles, and various other noises that indicated assent from dozens of species. The students who had been laughing at human physics less than an hour ago now wanted to learn it properly. Very well, Professor Zalthor announced, his tentacles gesturing in a way that showed renewed purpose. We will arrange additional sessions. Dr. Parker, Commander Hughes, Lieutenant Morrison, I hope you will agree to conduct seminars for interested students. We can offer university credit and compensation for your time. We will do it, Ryan said. Not for credit or payment, but because sharing knowledge is important. Our species only recently joined the galactic community. We have much to learn from all of you. If we can share what we know in return, that seems like a fair exchange. If the students began to stand, gathering their belongings and talking among themselves, but the tone was completely different from the beginning of the lecture. Instead of mockery, there was genuine interest. Instead of dismissal, there was respect. They clustered in small groups, reviewing the footage on their personal devices and discussing the physics involved. Several students approached the three humans as they prepared to leave. A Thrix asked about calculating intercept courses. A Bronthar wanted to understand the math behind the gravity assist. Two Kryn were arguing about whether the kinetic impactors would have worked as well against different types of armor. Jake answered questions patiently, using his datapad to draw diagrams and show calculations. Lisa discussed the limitations of kinetic weapons and when energy weapons were more appropriate. Ryan explained how human ships balanced protection, speed, and firepower within the constraints of their technology level. Professor Xalthor approached them as the crowd of students, slowly. 3 days after the lecture, Lisa Parker stood in front of a smaller classroom. This room held only 50 students, but every seat was filled. More students sat on the floor along the walls. Some ethereals floated near the ceiling, where they could see the teaching board. The room was designed for 30 students maximum, but word had spread quickly about the human physics seminars. Jake and Ryan sat to the side, ready to help with demonstrations or answer questions. Lisa had drawn the short straw and would be teaching the first lesson. She looked at the eager faces, sensory organs, and energy patterns of the assembled students and felt a moment of doubt. How did you teach basic physics to species that could manipulate quantum fields? Thank you all for coming, she began. I know many of you have advanced degrees in your species sciences. Some of you probably understand things about the universe that I can barely imagine. So I want to be clear about what this seminar is and is not. This is not me telling you that your knowledge is wrong. This is me showing you the foundation that human understanding is built on. You can then decide if it is useful to you. She activated the teaching board and drew a simple dot. This is an object in space. It could be a ship, a rock, a person, anything. Right now, it is not moving. We say it is at rest. The first question is, What does it take to make this object move? Akrin raised a hand. Force. You must apply force to change an object's state of motion. Correct, Lisa said. Now, what is force? Not the word, but what is it really? Several students looked confused. They had used force equations countless times but had never thought about what force actually was. Force is a push or a pull, Lisa explained. That is it. When you push something, you apply force. When you pull something, you apply force. When gravity pulls on something, that is force. It is just the thing that makes objects speed up, slow down, or change direction. She drew an arrow on the teaching board pointing away from the dot. We represent force with an arrow. The direction of the arrow shows which way the force pushes or pulls. The length of the arrow shows how strong the force is. A longer arrow means more force. A shorter arrow means less force. An ethereal spoke up. This seems very basic, Dr. Parker. It is basic, Lisa agreed. That is the point. Captain Foster won his battle using basic principles applied extremely well, not advanced principles applied poorly. So we start basic, and we build up from there. She drew another arrow on the dot, pointing in a different direction. Now, we have two forces acting on the object. One pushes left, one pushes right. What happens? They cancel out, Athric said. If they are equal strength, exactly. The object does not move because the forces balance. This is important to understand. An object with forces acting on it does not always move. It only moves if the forces are unbalanced. Lisa drew a third arrow, longer than the others, pointing up. Now the forces do not cancel. The object will move in the direction of the strongest force. She paused to let that sink in. This is how the Defiant avoided those energy beams. Captain Foster's thrusters applied force to his ship. That force changed the ship's motion, moving it out of the path of the weapons. The beams could not change direction once fired because nothing was applying force to them. They just traveled in straight lines. So the question became simple. Can we apply enough force to our ship to move it out of the beam's path before the beam arrives? The answer was yes, if we calculated the timing. Exactly right. A Bronthar raised a massive hand. But the calculations must be so complex with multiple forces. Gravity. Momentum. Let me show you how we break it down, Lisa interrupted. She cleared the board and drew a new diagram. This is the Defiant. These arrows are the forces acting on it. This big arrow is the main engine thrust. These smaller arrows are the maneuvering thrusters. This arrow is gravity from a nearby planet. Now, here is the key insight. We can add forces together, like numbers. If one thruster pushes with 10 units of force to the left, and another pushes with 6 units to the right, the total effect is 4 units to the left. She worked through the math on the board, showing how multiple forces combined into a single net force. The equations were simple: addition and subtraction. Several students leaned forward, following along with interest. Once we know the net force, we can calculate the acceleration. Acceleration is how quickly velocity changes. The equation is simple. Force equals mass times acceleration. If we know the force and the mass of the ship, we can solve for acceleration. Jake stood and walked to the board. Let me show you a real example. He pulled up data from the Defiant's battle. At this moment, the ship had a mass of 400 tons. The main engine produced 200,000 newtons of thrust. So the acceleration was force divided by mass, 200,000 divided by 400, which equals 500 meters per second squared. That means every second, the ship's velocity increased by 500 meters per second, Lisa continued. If we know the starting velocity and the acceleration, we can predict exactly where the ship will be at any future time. That is what Captain Foster's computer was calculating during the battle. Not quantum probabilities or dimensional shifts. Just position, velocity, and acceleration. An ethereal asked. But space is three-dimensional. How do you handle movement in all directions at once? We break it into parts, Ryan answered, standing to join his colleagues. Movement left and right is one calculation. Movement up and down is another calculation. Movement forward and backward is a third calculation. We do all three calculations separately, then combine the results. It sounds complicated, but it is actually easier than trying to solve everything at once. He drew 3 separate diagrams showing motion in different directions. In the Defiant battle, Captain Foster's computer was running these calculations hundreds of times per second, but each individual calculation was simple. Position plus velocity times time. Velocity plus acceleration times time. Basic algebra that human students learn at age 14. Lisa brought up the gravity assist maneuver on the display. Now, let us talk about the slingshot around the graviton beam. This is where understanding orbital mechanics became crucial. When an object falls toward a source of gravity, it speeds up. The closer it gets, the faster it falls. But if the object is also moving sideways, it does not fall straight down. It curves. She traced the Defiant's path with her finger. The ship entered the graviton beam moving sideways at high speed. Gravity pulled it inward, making it curve. But Captain Foster timed his main engine burn for the lowest point of the curve, where the gravitational pull was strongest. At that moment, the ship was moving very fast due to the fall, and the engine thrust added to that speed. When the ship came out the other side of the graviton beam, it was moving much faster than when it went in. We did not fight the enemy's weapon, Jake added. We used it. The Dravok captain provided us with a free acceleration boost. All we had to do was calculate the correct entry angle and timing. A Kryn student was making rapid notes. I am beginning to understand. You reduce complex situations into simple components. Then, you solve each component separately. Exactly, Lisa said with a smile. That is the heart of human physics. Break big problems into small problems. Solve the small problems using basic principles, then combine the solutions to handle the big problem. She spent the next hour walking through more examples. How to calculate the path of a projectile. How to predict where two moving objects would meet. How to figure out how much fuel was needed to change course. Each problem used the same basic principles: force, mass, acceleration, velocity, position. The students worked through practice problems on their data pads. Lisa and her colleagues walked around the room, helping individuals who struggled with the concepts. It was strange to see a four-eyed Kryn wrestling with basic algebra, or an ethereal trying to understand why objects in motion stayed in motion. These beings had mastered quantum field theory, but they found Newtonian mechanics surprisingly challenging. I think I see the issue, an older Bronthar said near the end of the session. We have been taught to think in terms of fields and probabilities. Everything is quantum, this and dimensional that. But Newton's laws are deterministic. If you know the starting conditions and the forces, you can predict the exact outcome. There is no probability involved. That is correct, Ryan confirmed. At the scales we operate at, quantum effects average out. A spaceship follows classical mechanics almost perfectly. You can ignore quantum uncertainty because it is too small to matter. That is why these old equations work so well. They describe what actually happens at human scale. Lisa called the class back to attention. Let me show you why this matters for combat. She brought up another human battle. This one showing the destroyer, Baltimore, fighting pirate raiders. The pirates had faster ships and more weapons. But watch what the human captain does. The video showed the Baltimore flying toward a large asteroid. The pirates pursued, firing energy beams and missiles. Then the human ship swung around the asteroid in a tight curve, using its gravity for a speed boost, and came out on a completely different heading. The pirates tried to follow, but miscalculated their approach. 2 of them crashed into the asteroid. The third was moving too fast to turn and shot past the Baltimore. which then disabled it with a perfect shot to its engines. The human captain understood exactly how orbital mechanics work, Lisa explained. She knew how much speed she would gain from the asteroid's gravity. She knew what angle to approach at. She knew where she would come out on the other side. The pirates had faster ships, but they did not have that understanding. They tried to follow her path but got the angles wrong. Speed does not matter if you are going in the wrong direction. The class session finally ended after nearly 3 hours. Students filed out slowly, still discussing what they had learned. Many looked dazed, as if their worldview had shifted slightly. Several asked when the next seminar would be held. Professor Zalthor was waiting outside the classroom. "How did it go?" he asked. "Better than I expected," Lisa admitted. They are bright students. Once they got past the idea that simple does not mean useless, they picked things up quickly. "I have been thinking about what you said in the lecture hall," the professor said as they walked. "About how we have forgotten the fundamentals. I reviewed my own education records. Do you know when I last calculated a trajectory by hand? 37 years ago. In my first year of university. After that, computers did it all. I never questioned whether the computer was right. I just trusted it." Jake nodded. "Computers are wonderful tools. But they are tools. If you do not understand what they are calculating, you cannot tell when they make mistakes, or when they are being fed wrong information," Ryan added. "In combat, sensors can be fooled. Computers can be damaged. If your crew does not understand the physics behind the calculations, they are helpless when the technology fails." They reached the exit of the building. Outside, the purple sky was darkening as night approached. The Galactic Institute's towers glowed with internal lighting, creating a beautiful scene. 6 months had passed since the first lecture. The Galactic Institute of Advanced Sciences had changed in subtle but important ways. In every classroom, instructors now spent the first week of each course reviewing fundamental principles. Students complained less and understood more. Exam scores improved across all departments. Lisa Parker sat in her temporary office, reviewing data from the latest round of student assessments. The results were remarkable. Students who had taken the human physics seminars performed significantly better in all their courses, not just physics. Understanding fundamentals helped them grasp advanced concepts more easily. A knock on the door interrupted her thoughts. "Come in," she called. Professor Zalthor entered, his tentacles moving with excitement. "Dr. Parker, I have news. The Dravok have requested human instructors for their military academy." Lisa looked up in surprise. "The Dravok? The same species whose ship Captain Foster defeated?" The very same," Zalthor confirmed. After the battle, their military leaders reviewed the footage extensively. They were shocked to realize how much they had forgotten in their pursuit of advanced technology. They want their officers to learn what human officers know. They have offered substantial compensation and full diplomatic recognition of Earth as an equal partner in the galactic community. "That is significant," Lisa said. The Dravok were one of the most powerful military forces in known space. Their recognition would elevate humanity's status considerably. "There is more," Zalthor continued. "The Viridian Collective has opened formal trade negotiations with Earth. The Kryn Assembly has invited human scientists to participate in their deep space research projects. Even the Thrix, who are notoriously isolationist, have expressed interest in cultural exchange programs." Lisa leaned back in her chair, processing this information. "All because of one battle?" "Not just the battle," Zalthor corrected. "Because of how your species approached the challenge. You were outmatched in every way. Yet you found a solution through understanding rather than raw power. That impressed many civilizations. But more than that, you were willing to share your knowledge freely. You did not hoard your secrets or demand payment for teaching. That impressed them even more." Jake and Ryan arrived moments later, having been summoned by the professor. When they heard the news, Jake whistled softly. "The Dravok want us to teach their military?" That is unexpected. They are a practical people, Zalthor explained. They care about results, not pride. When they saw that human physics worked better than their advanced systems in that situation, they wanted to learn why. Their initial investigation revealed what we discovered here: that they had become too dependent on technology they did not truly understand. Ryan nodded slowly. I can see how that would concern a military force. If your weapon systems fail or get disabled, you need crews who can adapt using basic knowledge. Precisely, Zalthor agreed. They have asked specifically for instructors who can teach their officers to think like Captain Foster, to break down complex problems, to understand fundamental forces, to find creative solutions within physical constraints. Lisa stood and walked to the window. Outside, she could see students from a dozen species working together on a physics problem. A Kryn was explaining something to a Bronthar, using hand gestures to illustrate force vectors. An ethereal was helping two Thrix calculate orbital trajectories. The sight made her smile. I think we should do it, she said. Not for the diplomatic benefits or the compensation, though those are nice, but because this is exactly what we hoped would happen. We wanted to share knowledge and help build understanding across species. If the Dravok are willing to learn, we should be willing to teach. There is one more thing, Zalthor said, his tone becoming more serious. The Galactic Defense Coalition has reviewed combat footage from over 100 human engagements. They have identified a pattern. Human forces win not through superior technology, but through superior understanding and adaptability. They want to incorporate human tactical training into the Coalition's officer education program. The Coalition wants us to train all their forces? Ryan asked, surprise evident in his voice. Not just train, Zalthor clarified. They want human officers integrated into mixed species units. They believe that having humans present will force other species to think more carefully about fundamental physics instead of relying solely on technology. Jake laughed. So we went from being the primitive new species to being essential military advisors in 6 months? The galaxy adapts quickly when survival is at stake, Zalthor said. The Coalition faces threats from several hostile powers. After seeing what one human frigate did to a Dravok warship, they realized that understanding basics might be the edge they need. Over the next week, representatives from various galactic powers visited the Institute. Each one wanted to discuss educational exchange programs, military cooperation, or scientific collaboration with humanity. Earth's government, initially overwhelmed by the attention, quickly organized a delegation to handle the negotiations. Captain Gregory Foster himself arrived at the Institute, having been promoted to admiral after his successful engagement with the Vorith's Fang. He was a quiet man who seemed uncomfortable with the attention his victory had generated. But he agreed to give a guest lecture to the students about practical applications of physics in combat situations. The lecture hall was packed beyond capacity. Students filled every seat, sat in the aisles, and crowded around the doors. Foster stood at the podium in his crisp uniform, looking at the sea of alien faces and energy fields. I am not a scientist, he began. I am a ship captain. My job is to take my vessel and crew into dangerous situations and bring them home safely. Everything I know about physics, I learned in service of that goal. He brought up the footage of his battle with the Vorith's Fang. The students had all seen it before, but they watched with new understanding now. After months of studying human physics, they could follow the calculations in real time. When I approached the Dravok ship, I knew we could not win a straight fight, Foster explained. Their weapons were too powerful. Their shields were too strong. Their ship was too large. If we traded shots, we would lose. So, I asked myself a different question. What advantages do we have? He paused to let the students think about that. The advantage was mass, or rather, the disadvantage of mass. That enormous Dravok ship massed 40 times more than my frigate. That made it strong, but it also made it slow to change direction. My ship could accelerate, decelerate, and turn much more quickly. If I could use that mobility effectively, I might survive long enough to find a weakness. Foster walked through his tactical thinking step by step. How he calculated the energy beam travel times. How he plotted evasion courses that would put his ship where the weapons were not. How he recognized that the graviton beam could be used as a propulsion assist instead of avoided as a threat. The key moment came when their weapons officer fired the graviton beam, Foster said. Most commanders would have ordered maximum acceleration away from that weapon, but I had calculated how much energy it would take to escape the gravitational field. And we did not have enough fuel for that. So, I looked for another option. He zoomed in on the trajectory plot showing the Defiant's path through the graviton beam. I remembered learning about gravity assists when I was a cadet. The math was simple enough. Enter at the right angle, apply thrust at the lowest point, and use the gravity to boost your speed. I had used it before to save fuel when approaching planets. So, I asked my navigator, "Can we do that with an enemy weapon?" My navigator, Lieutenant Ben Cooper, did the calculations in about 30 seconds. He confirmed it would work if we got the angle right. We had one shot at it. If we misjudged the entry angle or applied thrust at the wrong moment, we would be caught in the beam and crushed. But if we got it right, we would come out moving fast enough to reach their vulnerable spot before they could reposition. One side. End quote. Foster showed the moment of decision on the screen. I gave the order, and my crew executed it perfectly. Lieutenant Cooper's calculations were exactly right. We came out of the graviton beam with enough speed and on the correct heading to reach the gap in their shields. A Kryn student raised a claw. "Admiral Foster, how did you know there would be a gap in their shields?" "I did not know for certain," Foster admitted. "But I understood shield technology well enough to make an educated guess. Shields require emitters. And emitters need power conduits. And power conduits need to connect to the main reactor. The area directly above the reactor housing would either be heavily shielded or would be a gap where the physical connections prevented emitter placement. I bet on the gap. And I was right." He moved to the final part of the battle. The kinetic impactors were a calculated choice. Energy weapons would have been dispersed by their shields. Missiles might have been intercepted by point defense. But solid projectiles at high velocity? Those are hard to stop. The math is simple. Kinetic energy equals 1/2 mass times velocity squared. Make the rods heavy enough and fast enough, and they will punch through almost anything. The impact did not destroy their ship, which was important. We wanted to disable, not kill. The shockwave from 6 simultaneous impacts scrammed their reactor. Without power, they were helpless. Mission accomplished, and their crew survived to learn from the experience. Foster looked around the room. "The lesson I want you to take from this is not that humans are better than other species. We are not. You have technology and knowledge that we can only dream about, but we have something else. We are still close enough to our basic education that we remember the fundamentals. We have not yet developed the luxury of forgetting how gravity works or why momentum matters." He closed the presentation and spoke directly to the students. "Your species will probably develop better technology than Earth ever will. You will build faster ships, stronger shields, more powerful weapons. That is fine. But never forget that all your advanced technology is built on the same foundation as our simple machines. Force, energy, momentum, gravity. These things do not change. Understanding them deeply will make you better at using whatever tools you have." The lecture hall erupted in sounds of appreciation from dozens of species. Foster nodded to acknowledge the response, then stepped aside as students lined up to ask questions. Later that evening, Foster met with Lisa, Jake, and Ryan at a quiet restaurant near the Institute. They sat on a balcony overlooking the city, the purple sky now dark, with alien stars twinkling overhead. "I hear you three started something of a revolution here," Foster said, sipping his drink. "Not a revolution," Lisa replied. "More like a reminder. They just needed someone to help them remember why it mattered. The ironic thing," Jake added, "is that we are learning as much from them as they are from us. Their quantum field theory is incredible. Their understanding of dimensional mathematics is beyond anything Earth has developed. But they are teaching it to us in a way we can understand, because we taught them how to explain things using fundamentals." Ryan leaned back in his chair. "I think that is the real value of what happened here. Not just that we taught them our physics, but that we showed them how to connect advanced concepts to basic principles. They were floating in the clouds of abstract theory. We brought them back down to the ground. And now they can climb back up with better footing," Foster concluded. "That is good. Humanity needs allies out here. And the best allies are ones who understand us. If teaching them about Newton and Einstein helps build those relationships, then I would say your mission here was successful." Lisa raised her glass. "To fundamental understanding. May we never forget its importance." The others raised their glasses in agreement. They drank and watched the alien city lights twinkle below, thinking about how much had changed in such a short time. Across the galaxy, word continued to spread about the humans who had defeated superior technology through understanding alone. More species reached out to Earth, wanting to establish contact, trade, and educational exchanges. The human race, so recently alone in the universe, now found itself welcomed into galactic society, not as the primitive newcomers, but as teachers of something valuable that others had forgotten. In military academies on a dozen worlds, instructors began teaching Newtonian mechanics alongside quantum field manipulation. Officers learned to calculate trajectories by hand before relying on computer systems. The Galactic Defense Coalition added human tactical thinking to their standard curriculum. Slowly but surely, the balance between advanced technology and fundamental understanding began to shift. And somewhere in deep space, the Vorath's Fang had been repaired and returned to service. Its crew now included a human liaison officer, whose job was to help the Dravok crew think about basic physics before relying on their advanced systems. The arrangement was awkward at first, but gradually the Dravok came to appreciate having someone aboard who would ask questions like, "What happens if the computer is wrong?" Or, "Can we solve this using basic principles?" Professor Zalthor compiled the results of the human physics program into a comprehensive report. He presented it to the Institute's governing board, recommending that fundamental physics become a core requirement for all students regardless of their field of study. The board agreed unanimously. The 3 human instructors eventually returned to Earth, their mission complete. But they left behind a legacy that would last for generations. Students who had learned from them went on to become teachers themselves, spreading the gospel of fundamental understanding throughout their species. The message was simple but powerful. Advanced tools are wonderful, but they are no substitute for understanding what you are doing and why. Years later, when humanity faced new challenges in the galaxy, they did so with strong allies who had learned to think like them. Species that once mocked human physics now sought human advice on complex problems. The primitive newcomers had become respected partners, not through superior weapons or advanced technology, but through something far more valuable: the wisdom to understand that simple truths are often the most powerful truths of all. And in lecture halls across the galaxy, professors told the story of the human frigate that defeated a superior enemy through nothing more than good math and careful thinking. The story became a legend, a reminder that understanding the universe was more important than having fancy tools to manipulate it. The Defiant's victory was not just a military success, but an intellectual one, proving that sometimes the oldest knowledge is the most useful knowledge. The galaxy had learned an important lesson, and humanity had earned its place among the stars, not through force, but through the patient sharing of fundamental truths that had been waiting all along to be rediscovered. "Your species has given us a gift," Professor Zalthor said quietly. "Not advanced technology, but something perhaps more valuable. A reminder that understanding is more important than tools. That knowledge without comprehension is just data. I will be recommending to the Institute's board that fundamental physics becomes a required course for all students, taught using human methods. Lisa smiled. We would be honored to help develop that curriculum. As they parted ways, the three humans walked toward their quarters in the visiting faculty housing. The path took them past training fields, where alien students practiced with various technologies. But now those students were also pulling out data pads and drawing force diagrams, calculating trajectories, working through the basic equations they had been shown. Think it will make a difference? Jake asked. Maybe, Ryan said. If even a few of them truly understand what we taught today, it will spread. Understanding has a way of doing that. Thank you for watching. And we can see this 5 personnel watching, and concede in 46. Dispersed. I truly am sorry, he said quietly. I let my assumptions blind me to reality. That is unforgivable. For a teacher, everyone makes assumptions, Lisa replied. The important thing is being willing to change them when new information comes along. You did that today. Your students saw you admit you were wrong and adjust your understanding. That is a more valuable lesson than anything in the original lecture. The professor's tentacles curled in what might have been a smile. Perhaps. Thank you for being gracious about my mistake. I look forward to learning from your seminars. Graces. As the three humans finally left the lecture hall, they could hear students still discussing the battle, still trying to understand how simple physics had defeated advanced technology. The conversation would continue in dormitories and study halls, spreading through the student body and eventually to other faculty members. Mass. Kinetic projectiles follow ballistic curves. Captain Foster's tactical computer calculated where all those weapons would be and plotted a path through the gaps. The precision required. Bronthar began. Is what happens when you actually do the math correctly? Ryan finished. You all assumed human physics was primitive because it was discovered a long time ago, but we have spent centuries refining those calculations, testing them, improving our precision. While you were learning to manipulate quantum fields and fold space, we were learning to predict exactly how objects move through space and time. Both types of knowledge are valuable. We just never forgot the basics. None of them did. The Defiant spiraled through the defensive fire like a dancer moving through raindrops. Its path curved and twisted in 3 dimensions. The ship rolled as it flew, presenting different angles to the enemy weapons. Every thruster on the human vessel fired in carefully timed sequences, each burst pushing the ship exactly where it needed to be. Commander Ryan Hughes watched the alien students' reactions with satisfaction. Their earlier laughter had completely disappeared. Now, they watched in stunned silence as the primitive human ship did the impossible. The Defiant completed its spiraling approach and positioned itself in a location that made several students gasp in disbelief. The human ship was directly above the Vorath's fang, in the small gap between the primary shield emitters. It was a position that should have been unreachable, a blind spot in the Dravok vessel's defenses. Captain Foster's voice came through again, still calm and controlled. Target lock. Confirmed. All weapons. Fire. Man frigate. Jake Morrison leaned over to Ryan and whispered something too quiet for the translation systems to pick up. Ryan smiled slightly and whispered back. Lisa Parker closed her journal and sat back in her seat, her arms crossed. All 3 humans wore expressions of patient waiting. The alien students settled into their seats, ready to watch the expected destruction. They had no doubt about the outcome. After all, primitive physics could not compete with advanced technology. Everyone knew that. The professor had made it perfectly clear. The recording began to play, and the room fell completely silent.